Hello everyone. Today let's learn to write a program in Java to check whether an input number is a special number or not. A number is said to be a special number if the sum of its digits factorial is equal to the original number. Let's take an example. Say n is equal to 145. Its digits are 1, 4 and 5. Sum of its digits factorial 1 factorial plus 4 factorial plus 5 factorial. So what is factorial of a number? The mathematical definition is n factorial. Factorial is represented by the notation. This exclamation mark is used for representing the factorial. N factorial is equal to 1 into 2 into 3 into up to n. It's a product of all the numbers from 1 to n. Factorial of a number is the product of all the numbers from 1 to n. Or you can take in the reverse order, it's the product of all the numbers from n to 1. N into n minus 1 into n minus 2 into up to 1. So what is 1 factorial? 1 factorial is 1. So what about 4 factorial? 4 factorial is the product of all the numbers from 1 to 4, which is equal to 24. And 5 factorial is the product of all the numbers from 1 to 5, which is equal to 120. Now when we add all these factorials, calculated factorials, 1 plus 24 plus 120 is equal to 145. So the sum of each digit's factorial is equal to the original number. Sum is equal to the input number n. So we can say that 145 is a special number. An interesting fact is that in the base 10 number system, that is decimal number system, we have only a very few special numbers. They are 1, 2 and 40,585. Now, let's look at the algorithm to solve this problem. The first step is input the number. Next step is to separate the digits of the number. Now calculate the factorial of each digit. Add the calculated factorials. Now check whether the calculated sum is equal to the original number. If the calculated sum is equal to the original number entered is a special number. Now let's convert this algorithm into a Java program. As we have to input the number, let's import the scanner class from Java's utility package. Import java.util.scanner. The next step is to open a class to write the program. Public class special number. A meaningful name is given to the class special number. Body of the class is opened. All the executable commands in Java are written inside methods. So we have opened a method public static void check. Any name can be given for the method. The next step is to declare the sufficient number of variables to store the data in the computer memory. So I have declared int n, an integer type variable n, to accept and store the input number from the user. As we separate the digits of n by using a looping structure, n will become 0. So the original number we need for the final comparison. To store the original number for the future reference, one more variable num is declared as integer. We have to extract the digits of the number. To store the extracted digit, the variable d is declared. And each extracted digit's factorial has to be calculated. To calculate the factorial of a number, the variable f is declared and it is initialized as 1. F is initialized as 1 because 1 is the identity of multiplication. If we initialize f as 0, the entire product will become 0. And the variable sum is declared and initialized to store the sum of the factorials of each digit calculated. Now, as we have to accept the input from the user, the scanner class object is declared. Scanner type sc equal to new scanner system.in. The scanner class object sc is connected to your system's default input device. System.in represents the default input device of your computer. Now, let's display a message to the user. System.out.println, enter a number. To accept the input from the keyboard, scanner class's nextInt method is used through the object sc. N is equal to sc.nextInt. The original number after accepting from the keyboard is assigned to one more storage location. As we have accepted the input from the user and stored it in the memory location named as n and num, the next step is to separate the digits of the number and calculate the factorial of each digit. So, to separate the digits of the number and to calculate the factorial of each digit, we have to use a nested loop. So, outer while loop is used to take out the digits from the number and inner for loop is used for calculation of the factorial of each digit. Let us see how this looping structure functions. While n greater than 0, value of n is 145. 145 greater than 0. As the control comes to the while loop, test expression is evaluated to determine whether the loop's body has to be executed or not. Value of n is 145. 145 greater than 0. Test expression is evaluated. So, as 145 is greater than 0, test expression is evaluated to true. As the condition is evaluated to true, control enters into the while loop's body. Digit equal to n modulus 10. We are going to take out the digits from n. The last digit of n has to be taken out first. So, digit equal to n modulus 10. 145 modulus 10. Modulus operator will give you the remainder of a division. 145 divided by 10. The remainder of the division is 5. So, the last digit is taken out and stored in D. The next step is we have to calculate the factorial of 5. To calculate the factorial of 5, all the numbers from 1 to 5 should be taken and multiplied. 5 factorial. 5 factorial is 1 into 2 into 3 into 4 into 5. So, to take all the numbers from 1 to 5 and multiply, the for loop is used. This for loop is used for that purpose. Let us see how this for loop works. Now, the value in D is 5. For loop, index variable I is declared and initialized as 1. As first number which we have to take is 1. Int I is equal to 1. The value in digit is 5. Extracted digit is 5. So, here test expression is evaluated. After the initialization, test expression will be evaluated. Value of I is 1. 1 less than or equal to 5. Test expression is evaluated to true. So, control enters into the body of the for loop. The body of the for loop contains only a single statement. So, you need not enclose it as a block. To avoid confusion, I have enclosed the single statement inside a block. So, for loop has only a single statement to be executed. F is equal to f into I. Initially, the variable f was initialized as 1. F is equal to f into I. 1 into 1. The current value of I is 1. 1 into 1. So, 1 into 1 is equal to 1. As the closing of the for loop's body is encountered, control goes back to the header line of the for loop for executing the updation statement to update the value of I. plus I. Value of I is updated to 2. The current value of I is 2. After the updation statement, test expression is evaluated to decide whether the loop has to be executed or not. 2 less than or equal to 5. Test expression is evaluated to true. So again control enters into the for loops body. F is equal to F into I. The current value of I is 2. F has the value 1. So 1 into 2. So right now the value in F is 2. As the closing of the for loops body is encountered, control resumes back to the header line for the updation statement. Plus I. Value of I is incremented to 3. 3 less than or equal to 5. True. So control enters into the body. F equal to F into I will be executed. Current value of I is 3. To the current value of F, I is multiplied. Value of I is, current value of F is multiplied with the value of I. So 1 into 2 into 3. Now the value in F will be 6. Again control resumes back to the updation statement plus I. Value of I becomes 4. Test expression is evaluated to check whether the loop has to be repeated. 4 less than or equal to 5 is evaluated as true. So control enters into the loop's body. F equal to F into I. So the current value of I is multiplied with the value of F into 4. Closing of the loop's body is reached. So control resumes back to the updation statement plus I. Value of I becomes 5. Test expression is evaluated. 5 less than or equal to 5. Condition is evaluated to true. So control again enters into the for loops body. F equal to F into I. Value of F is multiplied with the value 5. So now 1 into 1 into 2. 2 into 3, 6. 6 into 4, 24. 24 into 5, 120. The value in F is 120. As we have reached at the end of the for loops body, control again resumes back to the updation statement to update the value of I. Value of I is updated as 6. Test expression is evaluated. 6 less than or equal to 5. Test expression is evaluated to false. False. So control goes out of the for loop structure to execute the following statements. Statements given after the for loop. So we have calculated the factorial of the extracted digit 5, that is 120. Now this calculated factorial has to be added to sum. Sum is equal to, the initial value of sum is 0. 0 plus calculated value of factorial, that is 120. Now the value in sum is 120. So last digit we have taken out, its factorial is calculated and it is added to sum. The next step is to remove the last digit from the number. To remove the last digit from the number, n is divided by 10 and the quotient of the division is assigned to the same storage location. N is equal to n by 10. So 145 divided by 10. Quotient of the division. Both the numbers are integer numbers. 145 is integer, 10 is also integer. So the quotient will be integer. The result of this operation will be integer. So 145 divided by 10 will result in 14. 14 times we can take 10 from 145. So the current value of n is 14. n is equal to 14. Now we have to extract 4 from 14. So the loop has to go for the next iteration. So again, before going for the next iteration of the while loop, we have initialized f as 1 because the same variable we are going to use for calculating and storing the factorial of the digit 4. So f is initialized as 1. In sum you have 120. F is initialized as 1. N is equal to 14. As the closing of the while loop's body is encountered, control goes to the beginning of the while loop. To check the test expression to decide whether while loop has to go for the next iteration. So the current value of n is 14. Test expression is evaluated whether 14 is greater than 0. Yes, it is evaluated to true. So control enters into the while loop's body for the second round of iteration. Digit equal to n modulus 10. 14 modulus 10. 14 modulus 10, the remainder of the division is 14 divided by 10. The remainder of the division is 4. So that 4 is assigned to D. Now the value in D is 4. Now we are going to calculate 4 factorial. So at this round of iteration, for loops takes all the values from 1 to 4. 1 to 4 as the value of D is 4. The initial value of I is 1. After the initialization, the test expression will be evaluated to decide whether the for loop's body has to be executed or not. As 1 is less than 4, test expression is evaluated to true. Control enters into the for loop's body to execute its statements. F equal to F into I. Value in F is 1. 1 into current value of I is 1. 1 into 1 which is equal to 1. For loop goes for next updation. I takes the next value 2. 2 is less than 4. So again F equal to F into I is calculated. 2 is multiplied with the current value of F. Again updation takes place. Value of I is updated to 3. 3 is less than 4. So control enters into the for loop's body. F equal to F into I is executed. So 3 is multiplied with the current value of F. Updation statement is executed again. 4 takes the value, I takes the value 4. 4 is less than or equal to 4. Condition is evaluated to true. F equal to F into I will be executed. Next updation, updated value of I is 5. 5 less than or equal to 4. Condition is evaluated to false. So control goes out. Control goes out of the for loop to execute the following statement. Now we have taken all the numbers from 1 to 4. 1 to 4 and multiplied. So 1 into 2, 2 into 3, 6, 6 into 4, 24. Factorial of 4 is calculated and stored it in F. Now we have to add that factorial to sum. In sum already there is 120. The value 120 is stored. Sum equal to sum plus F. 120 plus 24. So 144 is the current value of sum. Now remove the extracted digit 4 from the number. For that n is equal to n by 10. N is divided by 10. 14 divided by 10. The quotient of the division is 1. So the current value of n is 1. Before we go for calculating the factorial of 1, f is again initialized as 1. So sum is 144 and factorial is again initialized as 1. Current value of n is 1. N is equal to 1. So as the closing of the while loop's body is encountered, control resumes back to the beginning. The current value of n is 1. Test expression is evaluated 1 greater than 0. It is evaluated to true. Now we have to take out 1 from the number. Digit equal to n modulus 10. 1 modulus 10. 1 modulus 10 is 1. So the current value stored in D is 1. At this round of iteration of the for loop takes the value from 1 to 1 as the value of D is 1. Value of day is 1. So for loop takes the value, for loop's index variable, I takes the value from 1 to 1. That is, only once for loop will be executed. 1 less than or equal to 1, condition is evaluated to true. So f is equal to f into I is calculated. F is already 1, 1 into 1 is 1. So for loop completes its iteration when the value of I becomes 2. Control goes out, sum is equal to sum plus the calculated factorial. 144 plus f, that is 1, which is equal to 145. 145. Okay. Again, n is equal to n by 10 will be evaluated. 1 by 10 is 0. The quotient of the division is 0. F is reinitialized as 1. F is equal to 1. Now, as the closing of the while loop's body is encountered, control resumes back to the beginning header line of the while loop to check the test expression. 0 greater than 0. Current value of n is 0. N is equal to 0. So 0 greater than 0. Test expression is evaluated to false. So control goes out of the while loop. As the while loop completed its iteration and we have calculated the sum of each digit's factorial, the next step is to check whether the calculated sum is equal to the original number. The original number n became 0 after the execution of the while loop. We have already stored the value of n in num. So let's compare the value of num with the value of sum. Sum is equal to 145 and num is also equal to 145. So if the sum is equal to the value in num, display that num is a special number. 145 is a special number. In this case, 145 will be displayed as a special number. Otherwise, if sum is not equal to num, display that num is not a special number. Method is closed and the class is closed. Thank you for watching. For more videos, like, subscribe my channel and share.